Hello, I'm Brent Ursenbeck here with Mark LaLiberte again from Construction Instruction. For this podcast, we're going to talk about top 10 or 15 or 20 things that a builder should consider doing when he builds a home. We see builders do some things that are good. You know, what would be your, let's start with your top 10 list. What's the first item?
Let's pick the top 5, because I think we want to make sure that there's probably plenty, like you said. We want to make sure that we allow our industry, which struggles with change, to adopt things that we would say, yeah, that's important. Because I think sometimes they're like, come on, Mark, I can't do all of that. And you're like, fair enough. So I like this idea of eating the elephant one bite at a time.
Right.
So if we're going to say, so the things that matter most are this idea of getting the enclosure right. So when we look at the building enclosure, that's really this protection vessel that isolates us from the inside and the outside. And outside are wild beasts and complex weather and all that kind of stuff, right? So if I look at the human condition, we sure have a pretty narrow band of comfort. And I think it's gotten even less, right? When I grew up in Minnesota, if you were cold, you put on a sweater and sat by the heat register, right? Now, can you imagine your clients calling you up and go, hey, it's really cold here. Well, put on a sweater, click. That just doesn't fly anymore, right? So part of it is, if you think about us in our automobiles, I'm driving down the road and I'm gonna set my car at 71 and your wife sets the number at 74. Now, you two truly think you're in separate climate zones, but it's about perception. So building a house to maximize comfort is really what we're trying to accomplish. And the only way you can do that is in the enclosure, building a thermal bridge between the inside and the outside is a strategy. So in our climate, we say the outdoor conditions are fairly cold. You guys go down to -5, -10 in some cases. So I'm gonna say, so my optimum concerns are 5 below zero and 75 inside. And then in the summertime, I could be as much as 175 inside. So those are my extremes. And the only way to kind of manage that is build your house like a Yeti cooler. And so I'm trying to say, I'm going to put insulation on the wall cavities and around the outside. And then I'm going to insulate the roof to make sure it's properly insulated to control the energy that I'm paying for, because that's the difference. When I was heating my house with wood back in the 1800s, it didn't matter much. And electricity was cheap. That is no longer going to be the case. When we have electric cars, electrification going on across the country, the cost of energy is rising. So now the investment in energy efficiency in a better enclosure has a tremendous payback and investment benefit. Almost nothing that you put into the house provides an actual return on your expense. So I'm going to put money in. Should I add insulation to the walls? I think it'd be a good time. So adding insulation to the cavity, like you had said, do I spray foam or do I add a layer of insulation on the outside? I'd say that looking at upgrading the insulation in the walls is a very timely and important thing to do. Now we look at the attic and the roof system, and as I put the roof on, the old traditional trusses here in this part of the country set that bird's mouth right on the plate line, and there's almost no insulation at the edge.
Correct.
So one of the things that are super easy to do, and the industry can say to the lumberyard, send my truss out with a raised heel. And we've been doing that. I think I did my first house in 1984, had a raised heel truss on it, and it just raised it up high enough so that the insulation went from the plate of the house, the outside of my enclosure, to the other plate of the outside enclosure. I want a uniform blanket of insulation. You wouldn't want to put on a winter jacket and say, yeah, I'm just going to let the shoulders have missing insulation, but I'll be fine. The rest of me is covered, right? And that'd be absurd. So I think the house's enclosure has to be focused. The last piece of that piece is to say that window performance is worth upgrading for. Because the thing is, we put our windows in for, let's say, 25 years maybe, before we replace those. Is today, a house built today, is today the time that we step it up a notch? If the cost of energy will go up 50% in the next 25 years, that seems like it's a good time to do a 50% improvement in your insulating value. So maybe going with a triple glazed window, a well-insulated 2x6 wall, maybe a little insulation on the outside, nice raised heel truss, some good insulation in the attic space. Now I've got a good thermal insulation, I got a good window, and the last piece will be the air tightness. And so if I said my goal would be to say air seal the building using either a product like Aero Barrier, that kind of product to really air seal the building, or go around and make sure that that building is designed and built under 2 air changes per hour at 50 pascals, which is only managed and measured by a blower door. So now I've got all the pieces in town, all the players are capable, so now my enclosure's in place. Once I make those choices for a good enclosure, I now have to look at the way in which I'm going to heat and cool that. And today in a climate like this, you could probably use a really efficient heat pump. You could use a high efficiency gas furnace, but really looking at the equipment I put in now doesn't need to produce a ton of energy. It needs to just put in enough to get me to 75 or take out enough to keep me at 75. And if I can optimize that, that's a pretty good investment up front. So walls, windows, roof, mechanical systems are probably the fundamentals, and then the airtightness is the fifth. So if I got those 5 things right, what an amazing step that would be towards giving me an enclosure that could be modified to the next level of performance benefits, right? I might look at a monitor, I might look at humidification if the house is having a hard time stabilizing. But I think those are all key. You know, the one place we didn't talk about were what we have oftentimes in Utah, basements. And I think lower below grade foundations need to have insulation under their slabs, because we sometimes in Utah use our basements. And the walls should be well insulated too. If we could build that whole building enclosure, it's the right place to put the money now, because I believe whenever I come to this marketplace, people care so much about each other and about the future generation that's going to be here to do that. I'd like to give my house to somebody and sell it to somebody who says, boy, thank you for a house that's got a really low energy bill. It's incredibly healthy. It's amazingly comfortable. And this house has maintained its value. That's what we're supposed to do as a generation that takes the knowledge and the science of the day and apply that to what it is we're trying to accomplish. It's our job, I think. So those are the fundamentals. But you know, if you looked at other lists, all you do is maybe improve weather protection type, insulation type, window type, but we're getting down to, I think those 5 things would sure make me happier. If a builder said, I hit these 5 things, I'd go, yes.
Very good. You brought up one that, you know, I did some time inspecting too in the latter part of my career, about 13 years inspecting homes, and I remember the first time I failed an insulation inspector and the builder just freaked out. Right. No one fails an insulation inspection, he said. And I said, but it isn't done right. Correct. And it wasn't cut around the boxes. It wasn't behind the boxes. It, you know, it was crushed up, or there was gaps. I mean, everything was wrong with it. And I continue to observe poor bat insulation jobs. So tell me what you think about bib systems or net and blow systems versus bat systems.
Yeah, I think it's a great question. I'm always careful about this, but not really. I think that bats are a pretty poor product nowadays. I mean, if you want to use it for insulating a shed, I'm okay with that. But insulating a house today takes a lot more care, and it is very difficult to install a bat. Actually, I'd encourage any builder that's been still using bats to say, now you go try it. You go try to cut across that. The bats come out 14.5 inches wide. You try to put that in those cavities where only half of them are the right width. Everything else has got a block, a board. They're reduced in size, window complexity. You cannot put them in well, period. And if you did what you're supposed to do, and you did that and said, no, it's got to be at a level 1 installation, which is in the code, a level 1 install. Most of the bats are installed to level 3, which in all honesty is maybe half of its rated R value. So can you imagine telling a homeowner, say, by the way, you put your bats in kind of sloppy, and I'm going to have to put in a bigger furnace to compensate for it? Because that would technically be the truth, wouldn't it? That's so right. I'd say, well, what the homeowner would say, well, wait a minute, if I have a 2x6 wall, shouldn't the insulation fill the cavity? You're like, it should. So I blew fiberglass in my first house in 1986. The builder had no idea what it was. He's like, this is a terrible idea. It's going to make the house too tight. You can only imagine. So in 1977, when they first invented a blown-in insulation, now think about how long ago that is, Brent, right? You put up a nylon net in the wall, you can tear a little hole in it and fill the cavity with fiberglass or cellulose or blown-in products that now create a custom bat for every wall, regardless of size, wires, plumbing penetrations. Everything gets completely encased in a bat. And now it's done in every cavity to a higher density. Fiberglass bat, maybe a half-pound density. Blown-in fiberglass, 1.5, 1.8 pound density. The better R value, a 2x6, I can put in a 22, 23 R value. Now I've got a sound wall, and the other amazing part about it is sound. if you look at the fact that, I don't want to hear my neighbor mowing the lawn or yelling at their kids, right? So you put insulation like blown in insulation on the wall, and suddenly everything improves. The best insulation performance you're going to get out of fibrous products is to blow it in the cavity. And there's not much other choice. The next step would be that you're going to move towards maybe a foam or a foam type insulation. But I think blown in glass and blown in cellulose provide beautiful performance for the price.
Thank you. I'm going to throw out my number one, especially for Washington County in Utah, which is closer to your climate.
Right.
It's climate zone 3.
Yep.
Everything HVAC wise is put in the attic.
Right.
And as an HVAC contractor, it just drove me crazy because 20, 30, 40% of your load is overcoming that hot attic that you're putting your air handler
Absolutely.
and your ductwork in.
Absolutely. Yeah, and I think it's one of the things that I continually am amazed. Every time I look at it, I look up in the attic and go, you got to be kidding me. And it goes, well, it's got an R8 on it. I said, well, yeah, but the attic's running, let's say 140, and the ductwork is an R8, and the temperature inside the duct is 54 degrees. That's the delivery temperature of the air-conditioned air. So now I have a temperature differential between 54 degrees and maybe 150. That 100-degree temperature differential is far and away greater than any temperature differential the house will ever see, outside, inside, or in any of the seasons. So now I'm going to take the energy that I'm going to pay to heat it or cool it, run it up into the hottest or coolest part of the building, and let it get re-tempered back to a normal condition. There's no math that makes it work. That's been tried to, we've been trying to get the ducts out of the attic since I've been in this industry. Florida tried to do it. They tried to get all the ducts in conditioned space. They tried to get air handlers out of conditioned space because no one could service them up in the attic. So what we see is this transition towards leaving the ducts in the attic and then insulating the roof deck. So now everybody wants to push the insulation up at the roof so I can condition the whole attic. And I think that approach has caused some great challenges because there's an art form there. If you want to try to take a big tall attic like we have the houses here, you're putting a phenomenal amount of product and cost into making a place for the ducks to feel comfortable. And it's really a non-usable space, right? I'm not going to go up and store things up there. So it's a big expense to not do the right approach. And that's say, find a way to get the ducts into conditioned space. But the problem is that how am I going to hide a duct that's this big around?
Right.
So what would I do to get the duct diameter smaller? You go, well, you put in a better enclosure, put in better windows, and seal the building up tighter. So the furnace went from a 5-ton unit to a 2.5-ton unit. My ducts went from this big to this big. Now I can hide those. Maybe I could put them between the floor joists or some open web trusses between the first floor and the second floor, chase them up an interior wall. Now the insulation in the attic is a nice R60 blown across the lid in a place like Utah, and the ducts stay inside conditioned space. In other climates, for example in California, they're deciding that burying the ducts is now acceptable. If I am going to put them in the attic, why don't I lay them down on the attic trusses and then pour as much insulation over the top of them as I can to try to at least get them in a better conditioned space. If I do that, they've got to be very well sealed so that they don't get condensation on them, but we can do that. There's another company called RIA that's out of Arizona actually, and they're making the ducts smaller in diameter and starting to create a manifold system, kind of like we did with plumbing. What if I put the air into a box? On the back of the box, I had 4-inch ports and just put more of them around, keep the velocity low, and allow me to distribute maybe 4 supply registers into a room with smaller ducts that go between the floors and stay out of the attic. So the technology to stay out of the attic is now, lastly, the mini splits. And that's where I'm going to put the heating and cooling system in the room, mount it on the wall, maybe have 2 or 3 different heads and deliver cooling and heating right where the action happens. All of them depend on a good enclosure. So as we talked about at the beginning of this, the first order of business, give me a good enclosure. Everything else that follows becomes simpler and easier to do. So we start with the enclosure, then we marry the mechanical systems. And as an HVAC contractor, you'd say, perfect, you've given me a great enclosure. I can right size better equipment. I can put in some controls for air quality, for filtration, maybe some humidification. Now you're optimizing the conditioning of the house without some exorbitant fee. You're like, I can actually come in, put in a system for nearly the same price but give you a lot more features, because we're going to right size the things that I would have liked to put in before. Zone dampers, zone controls. Those are the things you'd say, boy, I'd like to do that. Shut off the kids' bedroom when they're out of town and gone. Drop those back off. That's control again. And so I think making sure that we look at this building as a operational enclosure is really ideal when we put all of those players in the right spot. And as an HVAC guy, you're the last guy in the line that goes, what did you give me? And you're like, oh, I mean, I got to go back up in the attic? And you're like, you got to go back up in the attic. Yeah. So I think we're getting closer.
Yeah, thanks. So just kind of summing up, you basically build a better enclosure. We have some products that we've talked about before. Mm-hmm. Can it be affordable to build with ICF, SIPs, and these types of products?
Yeah, it's a great question. Now, with innovation is usually an outgrowth of the challenges that occur. We see innovation happen when labor challenges are there. I have less labor. How do I speed things up? Innovation comes into play. The cost of energy goes up. Innovation comes into play. New materials, new applications. The cost of energy goes up and I start seeing triple glazing hit a marketplace just because I need innovation to solve that problem. So I would say that innovation is ICFs, insulated concrete forms, and structurally insulated panels, or SIPs. They've been around for 40 years. Right. And so it's not new technology, but it's the adoption of this to say, well, what are the benefits for me to look at a different system? And for in the mountains, for example, if you're building a house up in Park City, I would put on a SIP roof all the time. I would stop trying to make trusses part of my thermal enclosure, because now I've got 300 inches of snow laying on my roof, and somehow I'm magically supposed to keep that from being a problem. I can't spray enough foam against it because I've got conductive losses. I'm building a house in Arizona right now, and I put a 12.5-inch SIP panel on top of my roof, and in the desert. I want to have the difference between 100 degrees and 70 degrees be in our 50. I took the SIPs panels and I dropped them on the roof, splined them together, and I have a uniform level of continuous insulation across my roof. Underneath it is a simple truss to run wires and ducts. Done. On an ICF system, I can look at having the foundation from the footings all the way up to the roof be insulated concrete forms with a cement concrete in between. The concrete in between provides me incredible strength, right? And a lot of resilience. There's some thermal hysteresis that goes on as it stores and lags the energy flow. It makes great sense. Your most important word was economics. Can we afford to do that? And I think that as long as we apply the fundamentals of what economics is, what happens is we also get enamored with things called first cost. What's it going to cost today? Can't do it. You're like, wait. Is it easier to install? Does it provide continuous insulation? Does it lower the level of energy load over its lifespan? You might go, well, it does do that. Does it speed anybody up? Yeah, it actually speeds up the insulator. All the mechanicals get to run through and nobody's climbing through the attic. Yeah, there's a cost savings there. So if we make one choice over here, we have to agree that we're going to make those choices somewhere else to subtract, just like you did with the heating system. If I make a better system, where's my subtraction? Size, duct diameters, complexity. I don't need 9 ducts in this area. I can get by with 4. Those are all the things that we don't get credit for. So those technologies stay down because we don't give them anything other than a first cost look. How much is it? Oh, no, too much. Wait. It saves 3 steps. Yeah, I don't know how to figure that out, so we're just going to leave it back. And I think that we're going to watch that technology of better framing techniques, factory crafted framing, better systems to do that.
Thank you very much. That was a great discussion. Summing up myself in my mind, a couple of real easy things we can do are build a little bit better wall, net and blow, high heel trusses, 2 really simple things that have very little cost added to them that can make a big difference.
Very much so.
Thanks. We'll talk again.
It's a pleasure. Always nice. Thanks, Brad.
You bet.